Okay, so with these two lessons being a bit more difficult, and again, I kind of made that note in their mind that this quarter has a bit of harder content than last quarter. So you guys really have to stay on top of these. You cannot really get by not doing these videos. You can't be like, oh, I'll pick up on it. It's not going to be that easy, believe me. This content is a lot harder. And so we need to stay on top of these Edpuzzle videos as much as possible. Okay, so I wanted to go over some key points then. Because this stuff was a bit trickier, we're going to kind of review these two lessons and hopefully feel a bit more confident with it. So as always, make sure you're following along and copying this down. Summarize as needed. Key points, you don't have to copy exactly, but whatever you need to for yourself. So to find a scale factor, let's review this. We take one side from the what shape? The new shape. The new shape. And we divide it by one side from the what? Old shape. Basically, again, we're trying to find the number that multiplies our old shape to get the new. So even though we are going from old to new, we kind of think in reverse to get that number. So that's why we do new divided by old. Now to check your answer, if you're not sure, if you're like, I'm just taking a guess here, I don't know. Think about if the shape is getting bigger or smaller. So again, we're going from one shape to another. It will say that. It will name a shape to this shape. So looking at the picture, you want to ask yourself, are my numbers getting bigger or smaller the direction I'm going? If the numbers are getting bigger, your scale factor should be bigger than 1. So if we're going from here to here, I need to multiply by a number greater than 1, like twice as big or 3 times as big or something like that, yeah? However, if we're going from this shape and getting smaller, and again, you would be able to see that saying, okay, this is where I start, this is where I go. These numbers are bigger than these ones, yeah? So it's getting smaller. What ends up happening is your scale factor should be less than 1. So that means it's going to be a decimal, like 0.5 or 0.33 or something like that. It's shrinking. So if you say to yourself, okay, well, I can tell that my shape should actually be getting smaller, and you end up with a scale factor bigger than 1, you just need to flip it. You did it the wrong way. So if you realize that doesn't make a lot of sense, my shape is getting bigger and I got 0.3. Flip your fraction and you should be correct then. To find a side, we set up what's called a what? Proportion. Remember, that is 2 fractions that equal to each other, which we then cross multiply and solve. So if it says find AB or find KH, those are all sides, right? We know they're sides because they're 2 letters. They connect to make a side. So if it says something like that, we need 2 fractions that equal to each other. We cross multiply and go from there. Now to find an angle, though, this is different because angles, we use the fact that corresponding angles in 2 similar shapes are what? Congruent. I was kind of disappointed how many of you guys missed this in the assignment. You should have copied it down. Sides are proportional. Angles are congruent. It should have been in your notes, and then you picked the wrong answers in the assignment. I don't know what to tell you. Now, possibly you might need this information as well. You might also need to use the fact that in a triangle, the angles add up to 180. And this was slightly new information, but you should have written it down somewhere. Again, we did talk about this in the notes. A quadrilateral, meaning a 4-sided figure, any 4-sided figure, doesn't matter if it's pretty or not, add up to what? 360. You might need to use that fact as well. That yes, the angles in between the 2 shapes are the same, but also that if you're looking at a quadrilateral, all 4 add to 360, you may need to use that. So we're going to try just 1 or 2 more times, scale factor and setting up a proportion. We're going to try these 2. So find the scale factor from FEGH to RSTQ. Now, again, notice that my rectangle turns. So when I do scale factor, when I do new over old, I need to use a pair of corresponding sides. So take a moment. I want you to try this completely on your own. We know based off of this, which is the old and which is the new. Oops. There we go. We know which is the old and which is the new. And then we can tell based off of this as well, which sides go together. You can also tell sometimes based off the picture. I don't always recommend that, but you should be able to tell based off the picture which sides go together. Okay, so FEGH is the old, and this is the new. This is the old. This is the new. Now, hopefully we can see, because again, you can kind of based off the picture, that 8 goes with RS. Yeah, we turned the shape. So those sides correspond to each other. But again, we can see FE right here goes with RS. That's how we know for certain. So I'm not going to use QR. QR is just a distraction. I only have the 8 over here, so I have to use it. So think for a second. If I'm going from here to here, is my shape getting bigger or smaller? I'm going from 8 to 3. This is obvious, but is my shape then, if I'm going from 8 to 3, getting bigger or smaller? Smaller, right? 8 shrinking down to 3. So what that means is our scale factor should be less than 1. If it's not, we just need to flip it. So go ahead and try this. Put the new over the old. We are using 8 and 3, but which one is the new and which one is the old? Okay, so we just labeled that 3 is the new and 8 is the old. This again should make sense because 3/8, we can either leave it as a fraction or we can write it as a decimal, 0.375. This is good because our shape is getting smaller. We ended up with a scale factor less than 1. That's good. Again, if you did 8 over 3, you would get a number bigger than 1, and then you should be like, wait, that doesn't make sense. My shape is getting smaller. That's how we can tell. Okay, now in this one, we want to find FH. So it's the same picture as before, and I want to find F to H, so I'm going to call that X. So this is again that we know that F, what was it? F, I should have written this down. FEGH is similar to RSTQ. So I'm going to give you a moment to try it. Because we are finding a side, we need to set up a proportion. Go ahead and try and write your 2 fractions, and then we'll check. Okay, so I'm going to go ahead and write 1 fraction from one shape and 1 fraction from another shape using those numbers. But again, I have to make sure that I'm writing them the same way. And here's what I mean by that. I'm going to go ahead and put X on top. It doesn't matter. I could put 8 on top. That's fine. But I'm going to go ahead and put X on top and 8 on bottom. What that means is over here, what goes on top has to correspond with X in the other shape. So here's X. It's my long side. What corresponds with X in my other shape? 6. So 6 is going to have to go on top. This is my long side. What is going on with my mouse? And therefore 3 has to go in bottom. X and 6 correspond to each other. They're the long sides in both of the shapes. 8 and 3 correspond to each other. They're the short sides in both of our shapes. Once more, though, we can also tell based off of this what sides should go together. If you set up your proportion differently, don't erase it. I'm going to show you that when we cross multiply, you should end up with the same thing. So go ahead and try this real quick if you haven't already done so. Okay, we need to cross multiply here. And ignore these arrows. These arrows were just because I was talking about what corresponds. But when we cross multiply, I have 3 times x, which is 3x. I have 8 times 6, which is 48. Remember, The whole point of cross multiplying is goodbye fractions. I don't want to deal with you. So we divide by 3. We get that x equals 48 divided by 3. I feel like that's not 12, is it? No. 48 divided by 3. 16. There we go. So even if your proportion was different than this one, I think it's probably losing batteries. That's okay. Even if your proportion was different, you did it correctly if you still got that x equals 16. Okay, now going over Unit 6, Lesson 2 key points. So remember, there are only 3 similarity postulates. It is side, 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 angle, side, and angle, angle. These are the only 3 we can use in this unit. Now, if we're given numbers for sides, we do have to set up what is called, which I haven't said before, but this is what it's called, the statement of proportionality. Proportionality. What this is all those little fractions set equal to each other. Basically, this makes sure that the scale factor is the same for all of the sides. Yeah. So we have to make sure those fractions all end up being the same thing. Now, here's a little hint also. Super good. You make sure you have this written down because it's going to get some very easy questions answered. Boom, you'll have it right away. If you are given parallel lines and nothing else, notice again these little symbols right here tell us these lines are parallel. These little symbols tell us these lines are parallel. Now, if you're given nothing else, no other side information or anything like that, it's literally just those little triangle markings and no numbers. It is going to be guaranteed to be angle, angle. Because when we have parallel lines, we have angles that are congruent, right? Corresponding alternate interior, alternate exterior, those are all congruent types of angles. And so it's actually going to work out to be angle, angle. So super important thing to write down because that's going to make your life a lot easier on your homework, on your test. Now, a similarity statement, I've said this before in the last video, but we never really wrote it down. A similarity statement names the 2 triangles that are similar. So it might say something like triangle PQT is similar to SQR, something like that, yeah. So let's go ahead and let's try this. So are the 2 triangles similar? If so, state the similarity postulate, which is either SSS, SAS, or angle, angle, and then write the similarity statement, which again would be us naming the 2 triangles. So let's start off with seeing if any of these can even work. So take a moment, draw your picture, and label the information. Okay, we got ST is 7, TW is 12, TU is 5, and TV is 10. So there is one other thing here that we need to look at. If we notice, looking at these 2 triangles, in each triangle, I only have 2 sides, right? In the left triangle, I've got 7 and 12. In the right triangle, I've got 5 and 10. Well, that's not enough info because I don't have any postulate that's just side, side. However, they cross. What can we mark congruent? These vertical angles. Anytime we see a cross like that, vertical angles are congruent. So looking at what we have here, in the same way, guys, remember, we only need to look at one triangle. So ignore this triangle. We only have to look here. What postulate are we going to check for? Side, angle, side. That is because this goes side to angle to side. SAS. Now, again, it's not a guarantee. Because there are sides, we need to make sure that they are actually proportional, that a scale factor took us from one shape to another. So we are going to take, again, one side from one shape over the corresponding side to the other shape, the other side over the corresponding side. Go ahead and take a moment and just try. Write your 2 fractions. In each fraction, we want one side from one shape, one side from another shape. Okay, so I'm going to go ahead and I'm going to start with 7. Now, this is what's tricky. How do we know what 7 goes with in the other triangle? Well, because in this triangle, 7 is the smaller one of 7 and 12. That means it has to go with the smaller one over here. So it has to go with 5. So over here then, same thing. 7 to 5 is my fraction. The other one needs to be 12 to 10. That's because the smalls go together, the bigs go together. So what we need to determine now is, do these actually come out to be the same thing? Is this actually a true statement? So take a moment, figure out what these are as decimals. Okay, so I get 1.4 here, and I get 1.2. If you did different fractions, 5 over 7 or 10 over 12, or even 7 over 12 and 5 over 10, that actually would work as well. It doesn't matter, because what ends up happening is this is not a true statement. These are actually not proportional. Otherwise, when we divided them, we get the same thing. So our answer is just a big whomping no. Yes, we were checking for side angle side, but because this was not true, the answer is actually just no, and then we're done with the problem. Those triangles are not similar. Okay, so for the last one, same thing. Copy the picture, label the information, and keep going from there. Okay, so we got AC is 18, BC is 12, AB is 9, ZY we got 4, 3, and 6. So looking at our 3 postulates, which one are we going to check for? Side, 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 hopefully, obviously, because we are given 3 sides. Side, side, side. The numbers we are given are sides. Because we're dealing with sides here and we have 3 sides, we're going to go ahead and make our 3 fractions. Once again, we are taking one side from one shape over the corresponding side from the other shape. We have to match them up carefully so that my small sides go together, my medium sides go together, and my big sides go together. Go ahead and give it a shot. Okay, now you have options. I'm going to go ahead and go from this shape over to this one. Now notice that 9 is the smallest number here, so it has to go with the smallest number over here. So 9 is going to have to go with 3. If you did 3 over 9, that is totally okay, as long as everything else matches. So I'm going to go from 12 over to the medium side over here, which is 6. Nope. Whoo, I almost made a mistake. 4. Whoo, careful. 12 is the medium side over here. It has to go with the medium side over there, which is 4. I almost made a mistake. And then 18 has to go with the biggest side, which is 6. So let's see, do these all equal the same thing? Yes, they do. This is 3 equals 3 equals 3. This is a true statement. It actually works out. That means to get from one shape to the other, we can multiply everything by 3. So this is good. This is side, 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 because this is true. So now we can say yes, side, side, side. Now I'm going to go ahead and erase this information. We do want to do one more thing here. We do want to write the similarity statement. That is naming the triangles that are congruent. I'm going to go ahead and name one, and I'm going to relabel these sides actually because I need them here. 18, 9, and 12. We have 6, 4, and 3. I'm going to go ahead and name the first triangle ABC. Because I chose to name it ABC, we have to name the second triangle in a certain way. Go ahead and think about it. Again, as a hint, if AB is first here, the first 2 letters have to correspond to AB. And then I have my third letter. So go ahead and give that a shot. Okay, well, I chose AB to go first. And that corresponds with 3, right? They were in the same fraction together. So I'm going to put x, y first, and then I'm going to put z. So that is our similarity statement. This is our similarity postulate. So these two are our answers. Okay, so I hope that helped. I know it was kind of a bit more detail. Really, we just need to practice. So from here, you're going to try the assignment. Always ask me questions, send me pictures of our minds, and I can help you.